Go.
Hey Professor Melly, so this is my video presentation on how I completed the project number 1. So at first you gave us an encryption key, which was the word ciphering. I turned that word into a 3x3 matrix, and according to the Hill-Cipher method alphabet, I translated that into a numerical matrix. You also gave us 4 encryption vectors, and according to the alphabet, I made them numerical values too. So the first thing I did was I used Gauss-Jordan row reduction to find what my inverted matrix was. So when I did this all, and I posted all my work on the actual essay, but so for right here to summarize it, we had 3 pivots. Our first pivot was 2, our second was negative 24, and our third was negative 1243 over 48. So in my actual inverse matrix, I had all these numbers divided by 1243, but I realized that I needed to find my determinant, so I was able to pull out all the 1243 and make all of these fractions go into regular numbers. So my determinant of A, if you come down here, my determinant of A equals 1 divided by my pivots. So P1, 1 times P2, 2 times P3, 3. And when I calculated that number, I got 1 over 1243. So my inverse matrix is, my encrypted inverse matrix is right here. And then, so since my terms, my first term right here, negative 197, is greater than 25, I needed to perform the mod 26 operation on this matrix. So I know that according to the modular arithmetic, A equals B mod N, and due to a symmetric property it has, B also equals A mod N. So originally, I have 1 divided by 1243 equals B mod 26. I was able to multiply to both sides, so I got 1 equals 1243 N mod 26, or sorry, B actually. And then since the property, so I can switch it around, I have 1243 times B equals 1 mod 26. So the mod function means that I have some number, 1243, and then this gets divided by 26. So 26, or every multiple you get, whatever the last number, let's say you can multiply 26 so many times before reaching a number, and then the remainder is what your mod is. So I realized that I had a B which equals 5, so 1 over 1243 equals 5 mod 26. So I basically performed 5 times my inverse matrix, and then I performed the mod 26 operation, and I get this matrix right here, which ends up being my decrypted matrix. Okay, so next what I did is I had my decryption matrix, so I needed to multiply my decryption matrix by my encrypted vectors to try to find my decrypted vectors. So what I did was my decrypted matrix right here times the first one, and I got this vector right here. And I did this for all 4 vectors, and I realized that in all 4 of my new vectors, my terms were all greater than 25, so I performed the mod 26 operation on them. And I got my decrypted vectors, which are 12, 0, 19, 7, 8, 18, 12, 24, 11, and 8, 5, 4. And so this is my decrypted vectors, and this gives me my decoded message, which is right here. And according to the Hill-Cipher alphabet, my decoded matrix is math is my life. And that is the answer to the project, and a statement that I can also agree with. Thank you.